Smokeless powder and the fire service has been produced by the Sporting Arms and Ammunition Manufacturers Institute, Incorporated. The Institute, commonly referred to as SAAMI, is an association comprised of the nation's major manufacturers of sporting firearms, ammunition, and components. Since being founded in 1926, SAAMI has been actively involved in the publication of industry standards and participates in reviewing and proposing both domestic and international regulations to assure SAAMI products are distributed economically and safely. Over the years, SAAMI has gained a reputation as the voice of the industry. Some of the nation's 25 million shooters comprise a group known as reloaders, who rely on a sizable distribution network, including over 14,000 retailers to supply their reloading supplies, such as smokeless powder, bullets, shot, primers, and so on. To achieve optimum load performance for various cartridges and shot shells, there are over 100 different types of smokeless powders available for reloading from commercial sources. Retail powder canisters range from 1/2 pound to 12 pounds, with 1 pound, 4 pounds, and 8 pounds being the most popular sizes. The 8-pound container is the most prevalent maximum size due to regulations of the Department of Transportation. This video emphasizes safety in the storage and display of smokeless powder in the retail environment. In addition, the video addresses questions such as, is there a fire hazard posed by supplies of smokeless powder displayed in a retail store? What, if any, danger do these stocks of smokeless powder pose to firefighting personnel in the event of a fire in these establishments? What quantity limit should municipal fire prevention ordinances place on the storage and display of smokeless powder in retail stores? This video does not address black powder, which is more energetic and chemically different from smokeless powder. Black powder is regulated separately from smokeless powder for small arms. Over the last 10 years, experience and tests, patterned after the United Nations Manual of Tests and Criteria, clearly demonstrate that smokeless powder stocks do not constitute a fire hazard of any great significance. In fact, smokeless powder is less hazardous than many retail items, including aerosol preparations, propane, and flammable liquids. Smokeless powder for the tests was supplied by the 4 smokeless powder manufacturers who are members of SAAMI. A total of 220 pounds representing most of the popular types of powders were consumed in the series of experiments. Witnessing the tests were representatives from SAAMI, the International Association of Fire Chiefs, the National Fire Protection Association, the North American Fire Training Directors, and participating SAAMI member companies. Our thanks to the International Association of Fire Chiefs for their contribution in producing this video. The IAFC has concluded that limited quantities of smokeless powder packaged in approved commercial containers are not explosive when subjected to impact or a fire, and that any projections would not significantly hinder firefighting or other emergency response efforts in the vicinity.
When the Hazardous Material Committee chairman asked me to come to witness the burning of smokeless powder, I had a preconceived idea of what to expect. The results of the burn are much different than what I expected to see. A fair amount of heat is generated, but I would think that full protective clothing, self-contained breathing apparatus, and a fog hand line would be adequate protection for anyone in the general vicinity of the burn.
3 types of tests were conducted. First, previous footage of a UN 6A test is reproduced, which demonstrates that smokeless powder often does not ignite adjacent materials, even when heavily confined. Second, drop tests were conducted, which show that smokeless powder is relatively insensitive to impact. Third, bonfire tests of smokeless powder show no explosions and no significant projections. Smokeless powder often does not ignite adjacent materials in a fire. This previously shot footage of a UN 6A test simulates the reaction of smokeless powder when confined as part of a shipment. An electric match is introduced inside one inner package. Then the shipping case is placed on a metal witness plate. The package is then covered to a minimum depth of 20 inches in all directions. The 20-inch depth of sand is verified by third-party personnel. The smokeless powder is then ignited. As often happens with faster powders used in shotguns and pistols, only the first bottle ignited. The metal plate showed no signs of damage. Despite the heavy confinement, there was no explosion. Although protected only by a plastic bottle under confined conditions, the adjacent powder was not ignited. Smokeless powder is relatively insensitive to impact. The following drop tests demonstrate that smokeless powder will not ignite even when dropped from extreme heights. The height for these tests was based on a United Nations transportation test height of 39 feet. A rope pre-measured to 45 feet was used to set the height of the lift bucket, which exceeded the 39-foot UN standard. Also, in accordance with the United Nations standard, a 1/4 inch thick metal plate, approximately 4 feet by 4 feet, was placed on the ground in the drop zone. The smokeless powders used in these drop tests were carefully selected to demonstrate best and worst case scenarios. Hodgdon H870 is a dense, very slow burning propellant, shown here in a 1-pound bottle. Hodgdon Tightwad is a low density, very fast burning propellant, shown here in an 8-pound bottle. The first drop was a 1-pound bottle of Hodgdon H870, a relatively slow-burning smokeless powder. This is a close-up of the drop. The powder bottle was slightly dented but unbroken. No ignition occurred. The second drop was an 8-pound bottle of Hodgdon Tightwad, one of the fastest burning powders on the retail market. This is a close-up of the drop. The powder bottle was slightly dented but unbroken. No ignition occurred. The third drop was a fiberboard shipping box containing 2 8-pound bottles of Hodgdon Tightwad, one of the fastest burning powders on the retail market. This is a close-up of the drop. The fiberboard box was not opened or damaged. The bottles inside were slightly flattened on the bottoms, but unbroken. No ignition occurred. These drop tests show that smokeless powder is insensitive to impact, even when dropped from heights which greatly exceed normal retail conditions. Smokeless powder is extremely flammable, but does not explode in retail packaging. The fire is intense, but of short duration. The following bonfire tests demonstrate that smokeless powder is of equivalent or less risk than many other retail products, including common automotive products, aerosols, and camping fuels. The test criteria were based on United Nations specifications. The products were placed on an expanded metal table, 1 meter tall and 1 meter square, Wooden pallets were placed underneath the table and were heavily doused with liquid fuel just prior to ignition of the bonfire by electric squib. Aluminum witness stands of specified hardness were placed 4 meters from the edge of the table. Under UN guidelines, if the stands are dented by flying projections, or if metal projections fly beyond the stands, the product is deemed dangerous beyond the local vicinity. 4 bonfire tests were conducted as follows. Number 1, a 20-pound variety of smokeless powder. Number 2, a 100-pound variety of smokeless powder. Number 3, 100 pounds of fast smokeless powder in 8-pound containers. And number 4, 100 pounds of other hazardous retail products. This bonfire test consisted of 20 pounds of various smokeless powders in 1-pound containers. This assortment represents a small quantity of smokeless powder on a typical retail sporting goods shelf. The smokeless powder was quickly ignited and consumed. All the smokeless powder was now consumed. The burn table was undamaged by the fire. Upon inspection, no projections dented the witness stands, and no projections traveled beyond the witness stands. No explosion occurred.
The thing that surprised me of these burns, that even in large quantities, there was no explosion. There was a overpressurization or a popping noise that occurred from containers that would have occurred with any closed type of container. I was also surprised that no containers were projected any distance during the burn, which I thought would have happened with a fast-burning powder.
This bonfire test consisted of 100 pounds of various smokeless powders in 1 to 8-pound containers. This assortment represents a recommended maximum quantity of smokeless powder on a typical retail sporting goods shelf. The smokeless powder was quickly ignited and consumed. Although the fire is very hot, the tendency to ignite adjacent materials is reduced by the short duration and controlled diameter of the fire. All the smokeless powder was now consumed. The burn table was undamaged by the fire. Upon inspection, no projections dented the witness stands, and no projections traveled beyond the witness stands. No explosion occurred. This bonfire test consisted of 8-pound containers of Hodgdon Tightwad, one of the fastest burning powders available to reloaders. 13 bottles for a total of 104 pounds net powder were burned. The smokeless powder was quickly ignited and consumed. The total heat output per pound of smokeless powder is 50 to 75% less than retail flammable liquids and gases, which have storage limits 4 to 25 times greater than smokeless powder. All the smokeless powder was now consumed. The burn table was undamaged by the fire. Upon inspection, no projections dented the witness stands, and no projections traveled beyond the witness stands. No explosion occurred. This bonfire test consisted of 100 pounds of hazardous retail products. This assortment represents hazardous materials which are found in quantities of 4 to 25 times more than those allowed for smokeless powder. The hazardous goods took 2 minutes to ignite and began rupturing 3 minutes after ignition of the bonfire. These hazardous materials release 2 to 4 times as many BTUs per pound than smokeless powder. A 3/4 pound aerosol can, traveling approximately 55 feet per second, put a significant dent in a witness stand. Cans rocketed up to 135 feet from the bonfire. Camping fuel canisters continued to intermittently project flaming liquid into the air for several minutes. Upon inspection, an aerosol can dented a witness stand to a depth of 1 inch. Projections traveled beyond the witness stands to a maximum distance of 135 feet. Flaming liquid engulfed a witness stand, illustrating the tendency of flammable liquids to ignite adjacent combustibles.
I was most impressed by the burning of what can be considered normal commodities found in sports stores or retail establishments. Small containers became airborne with such power that they traveled considerable distance at considerable speeds, and I'm sure any firefighter in the area that would have been hit by one of these containers would have been injured. Should he have been hit in the head, I'm sure he would have been seriously injured.
In conclusion, we trust that the video scenes have provided you with a better understanding as to the hazards associated with smokeless powder that has been subjected to adverse conditions, such as severe shock and fire situations. In analyzing the tests depicted in the video, the following is a summary of our findings. Smokeless powder subjected to a fire is consumed rapidly. Consequently, the duration of the fire is short and often does not ignite adjacent materials. To the contrary, commodities such as flammable liquids and aerosols burn longer and have a history of spreading fire to other areas. Smokeless powder in various sized containers, up to an 8-pound maximum capacity, can withstand severe shock or a drop of over 40 feet without the powder being ignited. In fact, the drop test revealed that the contents are confined to the packages. Quantities of smokeless powder up to 100 pounds in containers of an 8-pound maximum capacity only burn and do not explode when subjected to extreme conditions of heat created in the burn tests. Missile hazard is minimal at relatively short distances from a fire involving smokeless powder. No indentations were detected in the witness screens, which were positioned at a distance of 4 meters, that's 13 feet from the fire. Smokeless powder in retail-sized containers subjected to fire constitutes a lesser fire hazard than many consumer commodities found in the retail environment. By comparison, aerosol preparations subjected to the same burn test produced serious indentations in the witness screens, thus indicating a high degree of velocity and hazard. Smokeless powder subjected to the United Nations 6C bonfire test did not produce any negative results. Therefore, smokeless powder involved in a fire can be considered a product that does not significantly hinder firefighting or other emergency response efforts in the immediate vicinity of a fire. When firefighters encounter a fire involving smokeless powder, full turnout gear is recommended, including full protective clothing, self-contained breathing apparatus, and a fog hand line.
From a firefighter's point of view, I see smokeless powder as just another hazard that we have to face in a day-to-day firefighting operation.
We hope you found this video helpful. For more information, please contact the Sporting Arms and Ammunition Manufacturers Institute. The video, Sporting Ammunition and the Firefighter, is a companion to this video and may also be ordered from SAAMI. The United Nations Manual, Recommendations on the Transport of Dangerous Goods, Tests and Criteria may be ordered from Label Master.